All right, how's it going, everyone? Welcome to Advent of Go. Yeah, I thought I was gonna take this opportunity to learn Go. Have like a proper backend language. Gordon, how's it going, man? Welcome. I got a special guest today. See this big butt? Yeah, his name is Odin, and he'll be joining my streams from now on. I'm not streaming alone anymore. Yeah, we're pair programming. Sure, good day. Yeah, but that's the plan. We are going to do Advent of Code in Go. Bear in mind, I am a total Go noob. All right, I'm taking this opportunity to learn more about Go and to just have fun. Show you how much I suck writing code. And yeah, how's that? I think it's gonna be fun. Boom, there we go. Oh, by the way, I added this little desk view. Hope you like it. I started computer science of MIT. That's cool. Sure, I'm enjoying Go a ton lately. Yeah, yeah. I think it's a really cool language. I think it's a really cool language. Yeah, so that's the case. I don't think I've done anything like Go previously. I've done JavaScript. That's like my main language. I've done Java. That's how I started. My first job, my first full-time job was Java. Then C Sharp, and then JavaScript, and then I stayed in JavaScript land. But yeah, I want to try out Go now. I was thinking, should I do Rust or something like that? But I think Go is more applicable. We can build more projects with Go and put it on the server. Not that you can't do that with Rust. I just felt like, it's more suitable for web stuff than Rust. I don't know. Rust looks like a tooling and like desktop and something like that. But yeah, that's why I picked Go. So let's learn. Let's learn Go. Oh, I also haven't done a full month of Advent of Code. So this is gonna be my first one. They on that MIT course, they will learn Lisp. Lisp is crazy, man. I haven't done Lisp, but I've talked with people who worked with Lisp, and they're like, "Yeah, Lisp is crazy." All right, let's check it out. I already created a repo, and there we go. I'm gonna paste this in the chat. We're gonna try to keep, all of our solutions here. Actually, my solutions, yeah, because that course is from the 80s. It is, yeah. And let's give it a go. Here's the solution. Here's where we are going to code the solution. And my idea is to basically build out. Here's how like the whole structure looks like of the repo right now. Here's the mod file. And my idea is to have multiple modules. For example, we'll have like read input module. We can have like some utilities module that'll help us, with parsing and stuff. And that's like a reason, we're gonna do that in that way so that I can and we can learn, modules, more complex project structures in Go. That's the plan. So let's see now. Let's start day 1. Hope you can read this. Something's wrong with the global snow production, and you've been selected to take a look. The elves have even given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problem. Okay, You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. There we go. You try to ask why they can just use a weather machine. It's not powerful enough. And where they're even sending you. They're sending us to the sky. And why your map looks mostly blank. You sure ask a lot of questions. And hang on. Did you just say the sky? Of course. Where do you think snow comes from? Duh. When you realize that the elves are already loading you into a trebuchet. Is that how you pronounce that? Trebuchet? Please hold still. We need to strap you in. It's still not started yet. Still not started. This is just like the beginning. All right. So they're basically loading us into a trebuchet, which is like the cannon for throwing people, right? Oh no, it's it's like this thing. This is a trebuchet. Trebuchet. I don't know. I don't know. This thing. So they're loading us into this. And they're gonna be throwing us at probably like specific locations so that we can see and like see what the problem is with the snow production going bad. As they're making the final adjustments, they discover that their calibration document, your puzzle input, that's gonna be our input, has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. There's our task. So we have a document, but it's messed up. And we probably need to like read the input, clean it up, and then basically do something else with the clear data input. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. There we go. On each line, the calibration value can be found by combining the first digit and the last digit, in that order, to form a single 2-digit number. For example, and here's an example, 1 ABC2, PQR3 STU 8 VWX. I think the idea is to like extract 12 here, 38, 1, 5, 15. And in the trebuchet, there's like just a 7. So like the first one is a 7. And the last one, starting from the right side, it's going to be 7 again. So like 77 probably. Yeah, there we go. In this example, the calibration values of these 4 lines are 12, 38, 15, and 77. On my hands, I don't know. It's like the iPhone. What was the center stage? It like does that automatically. I don't know. Yeah, in this example, the calibration values of these 4 lines are 12, 38, 15, and 77. Adding these together produces 142. That's the answer, right? 142. Consider your entire calibration document. What is the sum of all of the calibration values? To begin, get your puzzle input. And here's our puzzle input. Bam. All right, so let's copy all of this. Go back to Vim and basically do input.txt so we can save. There we go. 40 is the last one. No, it's not actually the last one. All right, I don't know what happened there. We just copy this, paste it. Now it's even weirder. You know what? I'm actually going to probably it's NeoVim. So let's go to projects, AOC Go, 2023, input txt. There's the input. Yeah. Okay, cool. TSGB, there we go. What's the last one? ONEN something. There we go. Okay, cool. We got the input. So basically, what we need to do is try to read it. Try to read the input and get the first and the last digit, right? Bear in mind, we're gonna like do a lot of learning stops. For example, I don't know how to create a new module in my project, so we're gonna do that first. And then I don't know how to read a file in Go, then we're gonna do that second. So this is gonna be learning Go along the way, you know. So my streams are gonna be a bit longer than just like solving the challenge straight away. Okay, let's see now. I'm gonna go in the top level directory, and I'm going to do modules, or just like, I don't know, let's see, go create another module, because this one is a module. Call your code from another module. There we go. Go mode init, that's what we did. And then we probably do another one. Yeah. Okay, let's do that then. I'm gonna create a new folder and call this module probably input. And I'm going to cd into input go mod init, and then we need to give it like a name, example.com/hello. So let's do github.com/nikolovlazar /aoc go / I don't know, input. Yeah. So there we go. We have a new Go mod here in the input. And we can do, probably again, main.go. And we can just use that new module back. Cool. Let's do this then. Function read input. Of course, package. I'll do package input. This file is within module input. This is not included in your workspace. To fix this, probably connect a Go work file that uses this directory. A Go work file. That's cool. Go work init, and then we have all the packages. Okay, go work init at probably the top level. Let's open a terminal again. Go work init. There's our go work. Let's do then go work add, right? Or use. Go work use. 2023 day 1 inputs. Use inputs. Okay, yeah. Okay. But the thing is, my Go mode is not here. The top level one is here. So maybe this should not be, or actually it should be an input, like a mod file. Within the module dot. Okay, so it's like go work use dot dot and then dot slash input. That's good. So no errors here. No errors here. Very nice. Let's just try something out. I'm gonna bring in format and I'm gonna do print line hello from input. Okay, and then we can go back to the main and expand the imports and do github.com/nikolovlazar/aoc go/input. There we go. Oh, it needs a semicolon. There we go. Oh, come on now. So we can probably do something like input, the module name dot read input. Cool. There we go. So if I were to debug this, we should see hello from input here below. There we go. Hello from inputs. Cool. Hey, that was easy. That was easy. Nice. So what we want to do now, we have the input.txt here, right? Let's go here and accept the path. Go read file. Buff IO. Let me just zoom in. There we go. Read file. And then we pass an absolute Blazer. Hey, thanks for the follow. Then we read the file, we check if there's an error. We'll print the file. No, actually the file location. No, not at all. I'm just starting out. That's why I picked to do the AOC in Go, so I can have like, you know, an opportunity to learn it basically. Okay, so everything's from OS, right? We read the file from the OS package. We open it and then using, it gives us like an F. I don't know what that is. Then we have B1, etc. All right, let's read this. Reading and writing files are basic tasks needed for many Go programs. First, we'll look at some examples of reading files. Cool. Checking most calls for errors. This helper will streamline our errors checks below. Cool. We're just gonna grab this and put it into our project. Perhaps the most basic file reading task is slurping a file's entire content into memory. That's probably that. You'll often want more control over how and what parts of a file are read. For these tasks, start by opening a file to obtain an os.file value. So this is another way to read a file. So this is one way. Load everything into memory. And this is another way. Yeah. So we can have a file value. The F is basically file. Read some bytes from the beginning of the file. Allow up to 5 to be read, but also note how many actual were read. So that's the make. You can also seek to a known location in the file and read from there. You can go to this position and then start reading. Okay, that's cool. Reads like ones above can be more robustly implemented with read at least. There's no built-in rewind. The buff.io package implements a buffer reader that may be useful both for its efficiency with many small reads and because of the additional reading methods it provides. Cool. So maybe we can actually do this. what I'm looking for is something that would allow us to do read line. You know, so like start reading a line, get that line, and put it into an array, for example. Then read the next line, put it into an array, so that we can basically grab the whole file and return the inputs in like a, you know, in an array. So let's do that. Read file line by line. Let's see how we can achieve that. Okay, so it opens it creates a new OS file. Go looks like Python. I think people are comparing it more to C, I think. But it has its own, you know, interesting syntactical, you know, decisions, like the colon equals. Okay, so like we can create a new scanner from the buff.io package. Optionally resize the scanner's capacity for lines over 64K. See next example. Okay. Yeah, air is basically a reader. So we can do .text and it prints these. Cool. There we go. So we can probably do that. First, let's figure out how can we get the path to that file.txt. You know, it's local. For example, if we're here in our main.go, we're going to, we can say like /input, but probably the OS package needs like a fixed package. So let's try that now. Go find file path. Runtime.color, let's see. os.executable returns the path name for the executable that started the current process. Okay, cool. Let's try this then. Let's create a new module. Utils. Oh, damn it. I created a file. Utils. Let's get into it. Go mod init github.com/nikolovlazar/aoc go utils. There we go. Now let's go to work and do utils, so it's part of the workspace. And then we can create a new file called, I think I can understand some syntax after learning those MIT lectures. Crucial to know the basics. Yeah. Modules mean folders. Not folders per se, but like packages, you know? Like collections of some specific logic, right? For example, we had the input, and into the input module or the input package, we're going to put every function that has to do with like reading the input, you know, or like parsing the input. Utils, we're just gonna dump everything like tiny little functions that we can reuse across the days. Yeah, and like we put, that's how we like group similar functionalities basically. Okay, let's check it out. So we want to do a file path, right? So let's do path.go, something like that. Yeah, cool. Package utils. Cool. We're going to import, what was the OS and path? Path/file file path. Let's see now. Get file directory. We're going to accept a file name, which is going to be a string, right? Let's try to get the error and, oh, sorry, the executable and the error. os.executable. If the error exists, it's different than nil. Whoops, wrong parentheses. We need to panic. That means just like throw if you're in JavaScript. Then we can create an X execution, like executable path, file path dot directory. There we go. And now we can print this. Oh, capital D because we're using it. So one more thing is that for functions that you export from a module, they need to be capital case. So like if it's lowercase, it's private. If it's capital case, it's public and can be used in other modules. So let's do fmt. Does it know that it needs to bring it? Print line, xpath, undefined, add import. Beautiful, cool. So I'm going to try to use this here. So let's bring in utils, right? Let's do, actually, let's do this. File path, or like input path is going to be utils.getFile directory, and the file name is going to be /input.txt. Okay, cool. Wait, what is this? Declared not used. Get file dir. Oh yeah. I probably need to, let's see, go to the that it returns a string, so I can just like do return xpath. There we go. Now it's just declared and not used. That's okay. We can just hook this up. There we go. So now everything's hooked, right? Yeah. We grab the get file directory from the utilities, and then we read. Yeah, we read it. Cool. So I'm gonna go back now. I'm gonna put a debug point. I'm gonna go get in. Put a debug point here and a debug point here and a debug point here. Actually, we don't need this one. Cool. Let's actually debug this. Cool. Go to line, step over, step in, and we want to do step into. There we go. Get the executable. There's no error, and the executable is this. Okay, debug underscore bin. That's not what we wanna achieve. That's not our directory. But okay, no error. Let me see the path. Oh, there we go. There we go. There we go. AOC-go. So what we need to do now is that's the executable. That's basically the root of the project. So what we need to do is do this. 2023 day 1 input txt, right? And let's go back to here, and what we need to do now is check this out. We're gonna do xpath file name. Is this how we concatenate? Oh, it's a plus. Okay. I don't know why I thought that this. Okay, cool. We don't need the format anymore. I'm gonna remove these two debugs. And let's go back to day 1. And let's see. The input path is AOC 2023 day 01 input.txt. See? That's what we want. Cool. So now that we have the input path, we need to read the file. And we're gonna basically do this. We need to read the file, and we're going to store that into lines, for example. Yeah. This is going to return a string array. Damn it. Go string array. Or slice. Okay. Like this. There we go. Cool. So we have the file path. Let's start bringing in the packages. We're not gonna need FMT. Probably not gonna need FMT. So let's do buff.io and OS probably. Yeah. I'm gonna create a new file in the utils. Errors.go, and we're just going to create that panic function. Check error. What's the type of the error? Is it like this? Panic. Come on. Go error type. What? Nope. Maybe we actually don't need this. You know what? Let's like not complicate things. There we go. So read input. Let's go inside. We have buff.io and OS. First, we need to open a new OS file to that directory. All right. So file and error os.open. And we're gonna pass the file path. Yeah, I think it's like it's an error with lowercase e. That's maybe the issue that we ran into. So yeah, if there's an error, panic. I don't know what we want to do, but just like let's do panic. And we want to defer file.close. And this means, oh, capital C. I always forget. This means execute this line when the function ends, right? So defer means put this here. So go like skip it for now. Remember it. Do the rest of the function, but then come back When you're done, come back and execute this. That's basically the fur. So now we need a new scanner, and this is going to be the reader line by line, and this comes from the buff.io package or module, sorry. Buff.io new scanner. There we go, and we need the file probably, right? Yeah. There we go. So for every scan, we have a text. Scanner.text. For every scan, let's actually print out. I think it's gonna be much simpler. Print line, scanner.text, right? There's another if here. If there's an error when we call scanner.error, and if the error is not nil, basically, if it exists, panic. So here's another thing. You have the opportunity to create a new variable before you check for it in Go. I've seen this. So like first, try to create the error, right? Call the error function, put it into the error variable. Is it null? If it's not, panic. That's basically it. Cool. So can we just like return? Yeah, let's just like return an empty string. So let's see. Let's go back to day 1. We already have the input path, and yeah, let's just like debug this. Failed to launch. That's not helpful. Damn it. That's not cool. Seriously? Okay. Okay. Probably because he wasn't used. Okay, so let's get inside. Put a breakpoint here. Continue to this breakpoint. And step out. So there's no error. As you can see. No error, but there's our file. Let's see if the file path is correct though. Yeah, that looks correct. Cool. No error. Close it later. Create a new scanner. And let's do scanner.text. Unable to evaluate. Okay. Oh, thanks, man. Why is that though? Like, what's the thing that you're like, hey, check it out. We can see the lines. Beautiful. yeah, so like let's just start appending them to our array, and then we can like return them. Let's do now lines. How did we do that? Go create slice. Slices are just like arrays, but you don't need to create like a restricted, you know, like that many elements. You can just like append, and it's like self-growing. Okay, so there we go. String, and we can do this basically. And instead of just printing scanner.text, we can do lines.append. There we go. Come on, lines, and then scanner dot. Damn it, I hate this. Scanner dot text. There we go. There we go. So we're creating a new. Let's see. It's never used. No. Now we're gonna use it. Return lines. That's it. Yeah. So what we're doing is create a new empty string slice. Start scanning. For every scan, for every like text, append that line into the lines slice. And actually append functions like this. It accepts the first like element is a slice, and then is like the elements. So this means basically give me the existing slice, right? And give me all the other elements that you want to append to that slice. And then I'm going to return a brand new slice, but like not modify your existing one. So this slice won't be modified. It's going to return a brand new slice. It's going to return a brand new slice. And that's why we need to do this. Lines equal append, and then again lines. So this is our base slice. And then we're going to append this execution right here, which returns only one line. Cool. Cool. So I'm going to put a breakpoint here. And let's see. Let's debug this again. Continue. No error. Close it later. Create a new scanner. Create the lines slice. 1, 2. You see how it fills up? Here. String length 6. Check it out. So the length is 10. The cap, which is capacity, is 16. And it's like self-growing. 14, 15, 16. And now it's going to jump to 32. Let's see. 32. So it doubles itself. See? Yeah. There we go. So I can create a new breakpoint here. Continue just so we can skip out. Our length is like 1,000. And the capacity is now 1280. But we have basically all of the lines from the file in here. Cool. Let's see if there's an error. No errors. So that we can return the lines, and there we go. And we can print them out. And it kind of did. Beautiful. Okay. I think we got this. And yeah. We can read the file. Now we have the lines, and we can start working on the actual solution, right? I'm thinking, should we merge these two lines and just be like read input and just give this to the read input instead of this, and like move that inside? Let's do that, you know? Let's do that. 2023 day 01 input.txt. We're just gonna do get file directory inside. So there's the file path. Actually, we're gonna do file name, and file path is going to be utils. There we go, utils.getFileDirectory, file name, and then we try to get the file path. Yes, it's a scanner for that code. Cool. So I'm gonna remove this, and now we're all clear. There we go. So now we can start with the actual challenge, right? The idea is to read the lines and get the first and the last digit from the whole thing, right? It can be the first character from the line, but it can be like a random position like this, in this case. So we need to start from the left, get the 3, or start from the right, get the 8. We can probably do regex and be like, okay, give me all of the digits from from that string, and then I can, then give me the first and the last from that array. So let's try that. Go regex. Cool. There's a regex package. It has a match. Matched, regex matched. We pass in the regex, and then we pass in the string. Okay. The output is true, false, and then there's an error because the regex is not correct. The regular expression. Okay, I think we can use this. Yeah, I think we can use this. Just give me 1 second. Cool. Let's do that then. Let's go back. And we're gonna bring in the regex package. So we wanna do for each of the lines, let's first create a new slice that we're going to keep the number, the digits in, right? Yeah, numbers equal, make me an integer, probably an integer slice, and then for each of the lines, how was 4? Go for someone. No, go for damn it. Loop. Yeah. 4. This is the ordinary 4. Is there another one, like a shorthand? 4 is while, basically. Golang for each. Yeah. In range. Index and element in range. And then we pass in the slice. Yeah. Yeah, let's do that. So for index and line. Was that assignment? Yeah. In the range of numbers. Right? Not the numbers, damn it, the lines. Yeah. We have the line here, so that's where we need to do extract the numbers from line. And we can try the regex now. Matched an error. We're gonna do regex regexp.match. Is it match though? It's probably match. Yeah. Yeah. Match. So let's first we're gonna pass in, what is this? Pass in this, and then we're gonna pass the line as the second argument. So what we wanna grab is like any of the digits. I'm gonna hit a plus because the plus, hey, what is that? Byte array. Okay. Match string. Okay, cool. Match string, there we go. Okay, let's check this now. So if the error is not nil, let's just panic, which means like stop the execution. And yeah. I want to run this now, but it's probably not gonna allow us. Yeah, this is terrible. Oh, come on. Okay, I'm gonna bring back the FMT module. Print line matched. There we go. Now it's used. I is declared, so let's do that. Oh, let's see. Regex.compile. You see that? Calling regex.matchString in a loop has poor performance. Consider using regex.compile. Let's see what's that about. Regex match string poor performance. Use regex.compile. My mistakes in Golang, regular expressions and slice. That seems like an article for us. Datetime string means something or not. Usually the service only takes around 2% of the CPU. The other, like, regular expression is quite expensive. Yeah, I know. Regexp is expensive. So we should be careful when we use it. Solution: build your own parser. Yeah, of course. That was not for us. It's just like it takes a lot. It takes a lot of time to extract it, you know. Victor, thanks for the follow. Appreciate it. Find all strings. How's it going? Okay, so like if we obtain the pattern like this, we can do pattern.find all strings. I think I understand what it is. Check this out. We're gonna create a new pattern outside, and we can do regexp.mustCompile, and I believe mustCompile is going to automatically panic. Yeah, it's like compile but panics if the expression cannot be parsed. Cool. Must compile, and then we're going to just basically not but like visual in quotes and just like paste this here. And this is going to compile, but now we have the pattern, right? And what we can do now is find all strings, and we can obtain that. So we can do, and we're not going to do this now, we're going to do digits equals pattern dot find all strings. Find all string. Yeah. We're going to pass the line. So here's the line. And what's the other one? A return value of nil indicates no match. Let me see. I'm not sure what the second argument is. We have it as -1 here. But okay. You know what? Okay, that's cool. That's cool. Then we have the digits here. And I would put the breakpoint now and actually try to debug this, okay? I'm gonna hide the UI. Close this. Debug points. Continue. There we go. So here's the line. The first line. Let's see. It's probably the amount of matches. Yeah, let's see. Digits is just 3 because there's only one digit and it's the last one. Let's check the input again. Yeah. There's just this digit here. Okay, cool, cool. So there's like the 3. So we want to find the first one and the last one. It's okay that it's only 1. It's just going to point to 3, you know. Let's do first is going to be digits 0. First, let's check if the length of the digits is like 0. We want to panic probably, or like continue probably. I don't know. Yeah. So don't do the rest of the stuff. If we have at least 1, give me the first one, and like the last one is going to be the last one. And let's see. Golang slice last element. Can we do like -1? Probably length. Yeah. Okay, let's do that then. Digits. And then get the length of the digits and -1. 1. There we go. And now we need to marry these two into a string and just basically like create a number out of it. So in our case, it was like the 3. It should be 33, right? Let's do first and last here. Debug. I'm actually go. Yeah. Debug this. Continue. There we go. The first is 3 and the last is 3. I'm gonna zoom in. Probably like this or like this. Like this. Okay. Okay, so we need to come up with an actual integer of 33 now. So the number should be first plus last. But we need to parse this somehow. Golang parse integer from string. String convert, probably string convert a to I. A to integer. We pass on the string and then we have the integer. Okay, cool. Let's do that. String convert here. There's our number, and we can do string convert a to integer. First plus last. Beautiful. It's going to return an error. Yeah. So if the error exists, let's just panic because we have a digit, we have a number, right? We have a digit, but it couldn't parse it, so that means we definitely need to do something about it. You know, we have a bug then. Okay, let's see. First digit is 3, last digit is 3, parse it. Number is 33, beautiful. So that means we can go up, uncomment this line, and we can do numbers, append numbers, and then the the new number. Beautiful. And then we need to sum everything up then. Let's see if there's like a quick way in Golang. Sum array of int. Let's see if there's like a one-liner, or I don't know, something like that. Or maybe you know what would be cool? If there is if there's like a, what was the name? A reducer in Go that we can use. That would be pretty cool. But let's see. Hey, Gordon sent me a picture. Nice. Let's see. For range, we already did this previously when we looped through the line, so we kind of know how we can do this. Grab the value, plus equals, there's a sum. Let's see if we can do something more, something cooler than that, you know? Yeah, hi guys. Blank index receiver, blank value receiver. It's still doing that. Isn't there like a math package or something like that? No. Golang, let's see. Math sum. Okay, here's a package. Let's find the sum function. There is no sum function. Okay. Go math. Sum. Oh, there we go. So, but this is probably a different package. I probably need to like install this. There we go. You see that? It has 4 stars. Oh, that's cool. That's cool. Okay, so like this takes into account all the different types that you can pass, but we know that it's going to be an integer, so we don't really need, you know, we don't really need to install that package in our case. And the math package, like the official standard math library, doesn't include a sum. That means let's just, you know, just loop through them and sum it up, right? So the sum is going to be 0. Then we're going to do another 4 from the range of numbers. And then we're going to do sum is sum plus num. And then we want to do format print line the sum of all numbers is sum. Is declared not used. I'm actually using this here. Damn it. Go fmt print variable. Oh, there we go. Actually, yeah. %d for digits. Only wanna just add the first element and the last of the slice. What do you mean? In here? These are basically all of the lines. You know, these are basically all of the lines. The challenge is for us to return the sum of all of the calibration values. %d for digits and S for strings, it's like some kind of vulnerability. Well, yeah, but it says what? Printline call has possible printf formatting directive. Oh. Like printf, there we go, printf. Yeah, we just want to see the number at the end. All right, so let's go here, debug it, and let's see what we get. Let's check out the numbers. We should see 1,000 numbers, basically. Yeah. Here are all the numbers. 33, 7s, 778s. No. No. These should be double digits. All of them. So we have an issue. We have an issue here. Oh, there we go. There's a plus. It should be exactly 1. Let me just see, regexer.com. There's a cool cheat sheet here. You can see exactly 1. There we go, you see that? Exactly 5, 2 or more. With the curly brackets, that means I can do exactly 1. Yeah. Debugging. Debugging again. I'm gonna close the UI. Now it's 3. I'm gonna continue so that we have the 7 at the first position and then 78 at the last. It should be just 78 with it's gonna take the first 7 and the last 8. There we go. So the digits are now 7, 7, 8, and we are going to grab the first one, the 7, and the last one, the 8. And then we get 78, and beautiful. So I'm gonna close this breakpoint and continue until the sum. My numbers array should have single-digit numbers. Look at that. They're all just single-digit numbers. Now we're correct. I'm gonna breakpoint here, continue until 55002 is the answer. Let's see. 55002. Let's see if that works. That's the right answer. We get 1 gold star. Congratulations, everybody. We solved it. Oh, there's part 2 now. Okay. Okay, let's go to part 2. But our calculation isn't quite right, damn it. It looks like some of the digits are actually spelled out with letters. 1, 2, 3, 4. Oh, damn. Those are now also valid digits. Equipped with the new information, you need to find the real first and last digit on each line. Cool. I'm actually kind of glad that we started doing this with regex. Okay, now let's see. 2, 1 as a digit 9 is going to be 29 instead of 11. Right? 29. Okay. So now what is the new sum? The input hasn't changed. Cool. All right, let's do the changes, right? We can't just look for this regex because this is just for digits. We also need to do separate stuff. Okay. Let me go back to regex and see. We basically need this type of this character class, right? Any of A, B, or C. But we need like literals. Match A, B, or C, D. Oh yeah, you see that? Yeah. So we can do basically 1 or 2, right? Or 3 or 4. Okay, bear with me now. 5, 6, 7, 8, 9. There we go. This should give us 1, 2, 3, 4 as like letters as well, like as words. And I'm not sure if we need this. I don't know. Let me see this. I'm gonna grab this I'm gonna put it here. Why is it matching V for some reason? Maybe we don't need this. Right? Let's go get this in and let's see what it finds. It finds the 3. Oh, there we go. We don't need the strings as well, right? And there's the 3 as well. Cool. Okay. Okay. We don't need the strings, like the quotes. And also the square brackets. And now we can see that. Cool. We're gonna find the digit. And check this out. Before we do this, we need to check if the first digit is a number or a string. Like, is it a single digit or a string? Yeah. And then we can like do basically parse them individually. So you see here, we need to, yeah, we need to do like some sort of a switch. Maybe let's create a map that's going to return us the integer value. So when we type map of 1 as in O and E, it's going to return us just 1 as an integer, you know, or like as a string. There we go. So how can we create a map? A map of string where the key is a string and the value is an integer. Cool. So let's go above the main because we don't need it. We can do this a number map? No. Number words. Okay. This is going to be a map where the key is going to be a string and we can return. We're going to return a string, you know, so that we at the end we basically marry the 2 strings. So 1 is going to be 1. 2 is going to be 2. And so on. If this is a YouTube video, I would just cut this part out. But now you have to stay with me. Yeah. There's 6. 7. 8. And the last one. 9. Expected declaration. Found number words. Maybe we should keep this inside, right? Missing comma before new line in composite. Oh yeah, it's the last one. Okay. Yeah, it doesn't wanna declare it outside. So but it's cool. It's cool. All right, so let's see. Now we're going to capture either integers or, yeah. Oh, you know what? Here's what we can do. I want to see what happens if I try to call, like invoke the map on this number words. Here's the, you know, here's the first digit, whatever it is. Is it like a string 1 or 1 as in O and E? And here's the last one. And I'm going to put a breakpoint here and run this again. And now let's see what happens. So digits, we have 3. The first one is O and E. The last one is a digit number 3. So the first one is going to be 1 as in 1, like as a digit. So our map works. But let's see what happens when we pass 3 as in 3. It's an empty string. So now we need to create like a fallback. Okay, if it's an empty string, then return, you know, the actual, yeah. I like that. I'm gonna do this now. Not first digit, but how do we... Okay, first element, let's do that. Let's get the first element. Let's get the last element. Digits of length of... Damn it, not these. -1. So there's the last one. And because there is no ternary operator in Go, we somehow need to... We probably need to just like make an if. My point is figure out the length of the first element. Is it 1? Then it's in a digit form. Is it more than 1? Then it's in a word, like in a letter form. If it's in a digit form, the first one is going to be just like the first element. If it's in a letter form, it's going to be passed through the map, you know? That's what I'm thinking. Or should I... Let's see this. Golang map return default is to return the 0 value for the value type. 0 or an empty string. Let's see. Oh, okay. So like it assigns the key first, and this is the key, this is the value, and it checks if the value exists. If it's not like an empty string. If it exists, return the value. If not, it returns. Okay. We're basically doing that. Define it yourself. It returns an integer, set is true. Okay, let's try something like that then. If I like this approach. So let's do v and okay. We're gonna do number words. We're gonna pass the first element and check if okay, whatever okay means, exists. I don't know. If it does, we want to... I'm gonna get these above like this. And I'm actually going to comment these and create new ones. So there's going to be var firsts. It's going to be a string. And var last is going to be a string. Actually, no. I'm gonna pass them through... I'm gonna do this basically. By default, they're going to be whatever's like first and last in case it's a digit. But if it returns an element from the map, then it wasn't like a digit, it was the letter form. So then I want to reassign first into the value from the map. Cool. Like this. I'm gonna put a breakpoint here. V is declared and not used. Okay. Format. Print line. There's V, it's used. And we want to do the same thing for the last element, and reassign lasts. So then we can marry these two and convert them to an integer. Okay, let's see. I'm gonna hide the UI. Here's the first. The first is O and E. The last is just like a number 3. So V is 1, OK is true. Okay, so like assignment, we can get V, but we can also get a value if it was okay or not. Well, we can actually use this, right? Yeah. Yeah, this works. I'm actually going to grab the value because it doesn't make sense, right? Okay. Let's try that again. First is 1 in letters, last is 3. First is going to be reassigned to 1 as in digit form. Then we don't touch the 3 because it already is in a digit form. And then we marry these two as in 13. Beautiful. Let's try the other one, 7, 8. There's 1 and 8. Just go, there we go. There's 1 and 8 in the word form, but we're gonna skip these. Yeah. Then we have 5 and 7. Then we have 3, 2, and 3 in letter form. So last element should enter the if. The second if should enter inside. There we go. 3, so it's like 33. Beautiful. Okay. Let's move on. And I'm gonna be here now. Sum. The sum is 55061. Let's try that. 55061. That's not the right answer. Okay, it's too low. But you're stuck. Make sure you're using the full input data. We are. There are also some general tips on the About page, or you can ask for hints on the subreddit. Please wait 1 minute before trying again. Okay, yeah. We have an issue somewhere. And let's see. We have a duplicate here. We can like delete these. It's gonna be the same. Okay. I guess let's just go and see. 1 and 3, so this should be 13. The number is 13. Then we have 7 and 8. The number is 78. Then we have 5 and 7, 57. Then we have 3 and 3, 33. Then we have 9 and 9, 99. Then we have 8 and 8, 88. 1 and 3, 13. 5 and 9, 59. Everything looks cool. 1 and 4, 14. 7 and 1, 71. Okay. 2 and 8. I'm looking at this, by the way. 2 and 8. And then I continue and I look at this number. 2 and 8, 28. 8 and 1, 81. 7. Oh, okay. Let's see this. 77. 77. 85. I'm gonna move this breakpoint here. 85. 9 and 1, 91. I don't see any issues. 1. 11. 1 and 2, 12. Yeah, so far so good. 55. 23. 31. 37. 82. What is it? 18. 13. 86. 86 again. 37. What is it? 33. 51. Ain't no way. 44. 13. 71. 24. 54. What is the use case? 18. 41. 71. 28. 22. 73. 33. 56. There's no issues. 55. I mean, I'm not gonna go through all of them, of course, because we're talking about like 1,000 numbers. Let's see this one. 9424869. So 99 should be like 99. It is 99. 1 and 7 is 17. What is the... Let's see. 2983. 83. ABC1. And then 3. Okay. 2, 4. 4, 2. 1, 4. 76. And all these together produce 281. Well, that's pretty much what we're doing. 33. 2, 5, 25. 5 is 55. 86. 66. Damn it. 42. I don't know. Why is it too low? Five 55061. We get that. What is it? There's no way. Yeah. Oh, look at this. Okay. 8-3. The T is actually shared between 8 and 3. So our regex discards the HREE. You see? Ooh. Also 79 is 79. Okay. Okay, okay, that's a hint. But yeah, 8, 2, 3. But 2 should be considered as well. Yeah, yeah. I'm not sure how we didn't catch that. Okay. Okay. It's a regex issue. So when we find all string, all successive matches of the expression as defined by the all description of the package command or return value of nil indicates no match. But it kind of overlaps, right? So A dot means AR, AN, AL. -1 probably means all of them. 2 AR, AN. There's -1 is for AA, and none is just an empty. Submatch is the all version of it returns slice of all successive matches of the expression as defined by the all. Okay, let's see. Maybe we want to use like a submatch. AX star B, AXX B. Ah. Should we do that? Puka, thanks for the follow. Yeah, maybe we should do a submatch. Okay, let's see. That's going to change the things a bit. Because it's going to return us an array of arrays. Yeah, cool. AOC is really cool, man. So there's our digits. And now I think we need... It's not gonna work now. Because I'm gonna put these because I want the errors to be gone. But I want to put a breakpoint here and actually try that that example, you know. Let's see. 1, 3. One, 8. Now we need, yeah. I'm gonna close this and I'm not actually going to read out the input. I'm actually going to create a custom input. The one that we have here as an example. 823 83 18, you know. 98. These are enough. Okay, let's see. We're going to find... We should find 3. 8, 2, 3. 8 and 3. And 1, 8. But with like a single E. O-N-E, I-G-H-T. You know, so they share the E. But find all strings, string submatch doesn't actually do that for us. eighth, and 3. Do we need a custom parser? Go regex match. Go regex match. How do we do this now? How do we even Google this? So it's not about the sub match. Let's try this now. I'm gonna get these. I'm gonna put them here. As in like new lines. Yeah, you see regex doesn't actually match 8. It matches 3. Maybe it's like a flag thing, case insensitive, multi-line, single line, Unicode, sticky, no. Should we do like lookups and stuff? Regex match words with overlap. The fundal doesn't yield overlapping matches. The expression does, however. Yeah, there's a lookup. You see that? Look ahead assertion. So that's what we need to do. Kind of like assumed, but okay, cool. It's a look ahead assertion. This is going to match if this matches next, but it doesn't consume any of the strings. So it's called a look ahead assertion. For example, Isaac and a look ahead assertion Asimov will match Isaac only if it's followed by Asimov. You see that? Okay. Yeah, I feel like we need to do some sort of a lookup function. A look ahead, something like that. Okay, A, B, C, D. Try to match 2 letters at a time. A, B, and C, D, and then E, it's not followed by a second number. That's why it's being discarded. It's being discarded. Okay. Turns out that when the regular expression matches the first 2 letters, it consumes them, meaning that the next match will be done against the rest of the input string, C, D, E. That's why the above regular expression doesn't capture overlapping pairs of letters. Cool. This is what look ahead and look behind assertions are for. They look ahead or behind to assert or check that the input contains some characters, but they don't consume those characters. Cool. So look ahead is question equals 9 replaces. Well, yeah, it's a solution, right? But we started off with like regex. I wanted to finish using regex, and I know it's possible. Okay, the first regular expression above has a look ahead assertion. That means, okay, look ahead with the 2 digits. When it's used to loop through the input string, it asserts that the current position is followed by 2 letters. It doesn't consume them because they are inside the look ahead assertion. In fact, the regular expression doesn't consume any characters because all matchable characters are inside the look ahead assertion. Okay, in that case, if I just like wrap all of this, these, there cannot be overlap for the digits, right? They're like single digits, there's no overlap. But for the letters or like the words, there we go. You see how it changed? For the letters or the words, there's gonna be an overlap. So I'm gonna wrap these into a positive look ahead, and then do what? Should I group them again? Nope. Okay, let's see now. It works similarly, but asserts that the current character is preceded by 2 letters. Here's a table of the look ahead, look behind assertion. Look ahead is AB, look behind is nothing. So where we are at the start of the string, the look ahead will produce AB, then it's gonna go one letter next, it's gonna be BC, then it's gonna go one letter next, and it's gonna be CD, because they're not, they're not consuming, it's not consuming the letters, so they're still there. And then the look behind is going to be AB, because here's the cursor, the 2 letters, because that's the regex right here. The 2 letters behind are AB. There was no 2 letters behind the cursor up until that point, so that's why they're nothing. So now it's AB, and then it's CD. Then we move on. Then it's BCDE. DE is a look ahead. BC is look behind. Then there's no look ahead because we don't have 2 letters. Nothing. But there's look behind. So let's do that now. Should we? How should our regex look like? How does it look like? Should I do? What is that? No. Interesting. Capturing groups. There we go. So we can like wrap these in a capturing group or in a non-capturing group. Should we do like a non-capturing group inside? It doesn't actually. Does make a difference. This is JavaScript, probably. It is JavaScript. Okay. I'm gonna remove this part so we can only focus on our letter or like word numbers. Oh, but you see, it matches an O character, not a word, but it matches an O character. No, I want to match an exact string. How do I do that? Do I capture a group like this? No. How do I do that? Because you see that O and E, but I want these three. Regex, positive, positive. Look ahead, just like look ahead. Capture exact words. I don't want to like capture. Atomic groups. And there's a positive and negative. There's a positive look behind. The positive look behind may not be supported in all browsers. What's the negative look behind? It's with a... Yeah. Alright, let's see. It's okay, we only want the positive. We want the look ahead. Finds the first bar, which has bar after... Okay, in that case, should I be doing this instead? You know? Like a bunch of look ahead functions? Is that the solution? Let's see. No, it's not a solution. But it still matches characters. Why are you matching characters? Maybe it should match. Maybe that's how it works, basically. See? There's one, and just one, and that's it. Okay, so one, it captures one if there's one inside. Okay. I mean, one afterwards. So, like, give me this one if it's preceded by another one. Okay, so give me this one if it's preceded by an 8. Oh, yeah, you see that? Yeah. Rich, how's it going? Do the strings need to be in quotation marks? No, it's gonna match. It's gonna match a quote character. A double quote character. Alright, so I kind of understand what's going on. So you see, we have this, but it doesn't include the last letter. Yeah, you see? So, like, we can do basically 1 or 2 or 3. 8, 2, 3. 8, 3, 7. Let's see, 8 and 9. Yeah, we need like a subgroup. Okay, so let's see, regex words with overlapping letters. A look ahead, a capturing group, and a word boundary anchor. Whoa. So regex. What was B? B is a word. Then there's a positive look ahead, and then there's a W plus. And the W plus is again a word. The word needs a space, yeah. So we're looking for yeah, we're basically looking for like a string literal for a string literal. If one as a word like one consecutive one appears before or after 8, we want to capture both of them. Hmm. All right, this is an interesting. So regex probably won't cut it, right? And find will probably cut it because it's going to find indexes. Yeah, it has to be with code. Hmm. We definitely don't need the submatch. Hmm. Yeah. This thing should have been 8 to 3. Yeah. What do we do now? Find is I don't think find is like a good solution. I mean it's really naive to use that, you know, like take the digits, like take the line, try to find ONE. Does it exist? Yeah, push it. You know, like find all the indexes, then try 2, then try 3, then try 4, then try 5, you know, like all this find index, find index, find index, and you're basically sorting the indexes later and then constructing the digits array based on the indexes. Yeah, it does seem inefficient, and there's got to be like a better way. I don't know. There has to be a better way. Well, happily concatenate arrays, then throw them through a setup to dedupe, then back into an array to process. What do you mean? And thanks for the follow, by the way. I just noticed that you followed. What do you mean? Like here's the words 8, 2 that uses the 8t, and then 3 at the end. Ah, yeah. Okay. Yeah, and it does capture 8 and 3, but it doesn't capture the 2 because the t for 2 is already consumed by the 8. Hmm. That's the issue. I'm gonna do a 30-second bio break, and I'm gonna be right back. I'm back. I have 3 arrays of slugs which I concatenate in specific order, but they had to duplicate them in sometimes, concatenate them 3 in the right order. Yeah. 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 Yeah, that's okay. But I think I kind of like thought of something. What if we did this now? What if we go back to the regex here? We do only this. We match the first 8, 2, 3. Actually, I'm going to do... I'm actually going to do a different... 8, 2, 2, there we go. I'm gonna do 9, 8, 3. I'm gonna match 9 and 3. And I'm gonna put them with indexes, right? With indexes. What if I remove the n and remove the... Well, actually remove the n and try to match again? Then I'm gonna match this. What if I then try to remove the a and match this, you know? What if I somehow did that as like a positive look ahead, but I'm only matching one character actually? You know, I'm actually matching one word only. Check this out. Let's see. Let's see. Just like one. Exactly one. And I'm gonna group these. Is it like this? Damn it. Doesn't matter. I'm matching 8, right? And I push 8 as the first letter, or like the first word that's being matched. Then I'm matching, and then I'm removing one letter from it, and I'm matching 2. You see? This is not a word. It's never gonna match, because if it does match, it's not gonna be 2. Let me show you. Same thing here, right? 9, 8, 3 with overlaps. What if I just like match 9, get the first one, push it into the array, destroy it, or like, you know, kill the first word, the first letter. Then the word doesn't match, but we can actually reuse the thing in the middle, right? 8. Cool. There's another word. Push it again. And the first letter, give me the index of the first letter of that matched word. Destroy it. Match again. 3. Push it into array, you know, into the array. Kill it. until there's no match. That way, I think we can go around the overlap, and it's not going to loop 9 times. It's going to loop like 3 times over the same line. How's that? Does it make sense? Would it work? Would we make it work basically? Because you can see it, right? There we go. The first one is that we don't care about the 3 at the beginning unless we come to it. We don't care about the 3. What do we have? We have a 9. Okay. Save it. Destroy it. Then we have 8. Cool. Save it. Destroy it. Then we have a 3. Cool. Save it. Destroy it. Do we have more? No. That's it. We work with 9, 8, 3. So give me 9 and 3. 93. Sum it up. Call it a day. Yeah. We just need to figure out how to get the indexes, Match 9. Give me the index of the first letter, or like the index of the word. And I believe this is gonna do that. So we don't want to find all. We just want to find the first one in this case. So let's see. Golang regex find string. There's regex match find all. There's find all string index is the old version of find string index. Okay, there we go. Find string index. Find string index. Returns a 2-element slice of integers defining the location of the leftmost match. See? Leftmost. In S, that is the string of the regular expression. So we want to do that, and we want to loop until we basically run out of indexes. So let's try that. Let's try that. I'm going to check this out. We have the digits here, right? It's going to be a string array. Check this out now. We're going to do a for find string index like this. And that returns find string index, that returns an array of indexes and indexes. We're going to loop as long as we have indexes, right? There we go. So let's try that. So we have the indexes, find string index. Yeah. We have the indexes. And then what do we do then? A, B, and then something else. There's A, B, and something else, and then 3. Oh, it's going to be a nil. Okay, it's going to be a nil. That's all right. But we have the indexes now. We have like the firsts. We only want one index. The match itself is at slug 1, 2. A return value of nil indicates no match. Okay, so let's check this out. Must compile. So the regex is AB and question mark. Question mark was 0 or 1. 0 or 1. Ah, okay. Okay, what? AB or question mark? Find string index. It says 1 and 3. Oh, wait a minute. Is that like that is a really bad example. Let's try this. Tablet. AB question mark. It's probably like the first position, and then you see the range 1, 2. This one is like 3 probably. 2 element slice. Defining the location of the leftmost match in S, which is the string of the regular. The match itself is at 0 and 1. Oh, okay, I can run something. What if we do able? 1 and 5. Okay, you see that? Yeah. So like it's 1 and 5. Tablet. There we go. The output is 1 and 5. It starts at the second, like 1, 0, 1. And it ends 1 through 3, 4. It ends at 5. But it does not include 5. So there's our word. It's okay. We can just grab the 1, save it, destroy it, basically, from this string. Yeah. There we go. There we go. So, check this out. We have the... Where am I? We have the indexes, right? We have the digits here. Here's what we're going to do. What is going on? There we go. The issue now is that we know that we have a match at that index, but we don't know what's the match, right? How, like, can we get a string holding the text of the leftmost match in S? If there's no match, empty. If regular successful match as an empty string, use find string index or find string submatch if it's necessary to distinguish these cases. Okay, maybe we need to use like find string index or find string submatch. Slice of strings holding the text of the leftmost match. Okay, this is like a super bad example. Let's try the tablet one. Let's see what we get. We just get able. What if we probably need to execute this twice, First to get the index and then to get the actual word. Still not optimal. But that would allow us somehow to... It would allow us, right? Because we need the word and we also need the index. We don't know what the word might be, Plus, we also have the letters here. Sorry, the digits. we have the same pattern. Okay, so let's try this then. Let's try words, pattern, find string, and we'll just pass the line. And find string returns a string holding the text. Yes, this is foo, so let's do able. And then do tablet. There we go. We also need to figure this out. Actually, you know what? I'm gonna turn this into like a manually ended for. There we go. Give me the indexes, right? If there are no indexes anymore, break out of the for. But we're going to loop in this for just so we can fill up the digits. Just so we can fill up the digits array, right? So then we do this. Cooking time, all right. We're gonna do this. Matches instead of words, because it might not always be a word, you know? Yeah. So give me the matches now. Actually, give me the match. And the match, we want to push that to the digits, right? Get that in. And then from the index itself, we want to modify the line. You know? Get the line and destroy the letter at that specific index. Let's see. Go. Remove character at index. Delete character. Dude, thank you so much for tuning in. And it's already late. Yeah, it's like almost midnight. Take care. Runes, you see this? Replace at index. Replacement and the index. There's a rune. Okay. Strings are immutable in Go. You have to convert it to runes, then modify it, and then convert it back to a string. That's good. You can use runes instead of bytes. That will work on Unicode as well. So there's the replace, right? You take in the string, which is the line, in our case, the whole line. We get the rune, and we don't really care about that. We only care about the index right here. We just want to not replace. Or like, we can replace it with an empty, right? Yeah. Okay, let's try this, you know? Let's try this. Where was that? There's no accepted answer. This guy's doing benchmarks. is the fastest option for a large string. Okay, check this out. Yeah, we can actually do that. So line equals line from 0 until the, let's see, we have the indexes, and then we can do start. And this is going to get the no. Okay, let's do indexes from 0. There we go. So start should be an integer. There we go. Yeah, start. And then we're going to concatenate a line where we start from the start plus 1, and then so on. That means we're basically skipping the letter that's at that specific index, you know? We modify the line and then move on again in the for, so that the line won't match the same word anymore, because we're just gonna destroy that word, you know? And that's how we can fill up the digits array. Let's try this. You know, let's try this. And we're gonna stop when there are no more indexes. I'm going to do 8, 2, and instead of 8, 2, 3, actually I'm gonna do, where was this one? 9, 8, 3. That's gonna be the first one. 9, and then 8, and then 3, so that we have a chain of 3 consecutive words that share a letter between themselves. Cool, let's see. All right, indexes is 0 until 4, because the first one, the first match is 9. Beautiful, right? It starts off at the 0 index, at the first, and it's until the 4th, but we don't even care about the end, you know? So digits is empty right now. We're going to append 9, and we're going to like modify the line so that we have 2, 7. It's not 0, 4 anymore. The start is at 2, and the actual match is 8. There we go. 9, 8, right? 9, 8, 3. And then we're going to match 5 and 10. Beautiful. 3, beautiful. And then we don't have any indexes, and we break out, you guys. We break out. There's the first 9. The last one is 3. Holy moly. 93. How about that? Huh? How about that? What if we did this now? 9, 8, 3, 4, 5. How about that? So, and I'm actually gonna put that as like the first, word. So we see we want to get 9, and then we want to get 8, and then we're gonna get 3 and 4 and 5. The digits should contain all of these words basically. All right, let's see. The first one is 9. Beautiful. Push it. Then we have 2 and 7. Should be 8. Beautiful. Then we have 5 and 10. 3. And then we have 9 and 10, which is like a single, which is like the 4. Okay. I like this. There we go. We have the 4. And then we have 9 and 13, which is just 5. 4 letters between. No more indexes. Digits have 9, 8, 3, 4 as in digit 4, and then 5. Yo, I think we actually broke this. I think we actually cracked this. Let's see. Let's see. Input. Where's input? Oh yeah, we have the... Okay. Ain't no way. 1. Let's see. Then we have 3, right? There's our 3. And then we have a letter 3 at the end, 27, 28. Letter is in digit, and then we have no more, no more indexes. What is the sum going to be? 55093. It's larger than last time. Okay, let's see. 55093, was it? Are you ready? There we go. There we freaking go. Whew. All right, how did you like this? How did you like this? You know what? I was honestly I was honestly scared that, not scared, but like I thought, what if, for example, we destroy one word, like we have 8, right? And we remove the E, so we got IGHT, but then from the IGHT we kind of build another word from it, not from the like last time. Actually, it's not a bad case. It actually works out just fine. Yeah. We did it. We did it. There's the algorithm. Match the first one, break it up. Match the second one, like the next one, break it up. Match the next one, break it up. Until you actually have no more matches. Then you're done with the line. Figure out what's the first and the last, sum them up. This was a good challenge. And imagine if this is like day 1, imagine what we have on day 25. It's gonna kick our butts. But this was pretty good. This was challenging. It's fun. Just written APIs in Nest.js. Next thing on my list is a website in Vue. I'm learning Vue right now, and it's pretty cool. I like it. We're building an interesting project at work. It's for building links. Let me just try one thing. Link tree. Let me try this. This is link in bio, right? Yeah. Let's go with Google. I don't care. Just create one. Svelte? No, I haven't. Linktree. My username. You know it. There we go. Oh, come on now. Don't do this to me. Is it because I use Brave? Your name. My name is Lazar Nikolov. Oh, come on now. Tech. There we go. Edutech. Let's do that, for example. Free. Por favor. Actually, hold on a second. Themes. The idea is to have a Linktree app, you know, that can allow you to, it's going to allow you to put your links like this. Zoom in. Yeah, username or URL. Let's see. There's my Twitter. There's my YouTube. There's my Twitch. So, you know, you do these things. And you have a profile, right? What if I want to share, customize and share your link tree? And this is the only URL that I have right now with these links. The idea was to build a project where we can create collections of links, just like Linktree does, right? Here's a Twitch, here's a Twitter or YouTube, etc. You can throw in an ordinary, just like a plain URL, some random website or an article or slides or Google Doc links, right? but do that with multiple Linktree accounts. And we don't have the notion of account. We have plates. I called it buffet, you know, like eating buffet, and it's like all you can link basically. And the idea is to have a link tree, but you can create multiple collections like this one. And we needed that for example, when we do talks at conferences and workshops, we want to share all the links that we mentioned during the talk or workshop. We usually do that on the last slide, but we ran out of space. You can fit so much links on one slide. So we wanted, like, we were like, okay, let's try Linktree or Bento. They only allow you to create one collection, and if you update your Linktree later for a new talk, then people who are watching your old talk are gonna try to visit your Linktree. They're gonna see totally different links that have nothing to do with the previous talk. So that's the project. That's what we're working on, and we use Vue. We use Vue to build. We use Next to be more exact with Supabase. Yeah, everyone I know uses React, but I don't really like it. Yeah, I feel you on that one. I don't have like super. I don't have like, I don't know. I'm not weird about React. React is actually the framework that I know the best. I'm learning Vue right now, but yeah. So that's basically the project, and we're building that in Next. We're learning Vue. But yeah, that was it. Let's actually push now. First, let's leave comments, right? Define a map to convert word numbers into digits. Read the input. Define the regex pattern to match digits and number words. There we go. Loop through. Not loop through. We're not looping through. We're looping until. Loop until there. Yeah, loop until there are no matches, basically. Match the regex with the single line. Define the start index of the match. Match the or not match, but like find the index of the match of the regex match within the single line, and then we do match the regex to obtain the value, digit or number word, or like word number. Let's call these word numbers. Yeah, like save the value and then modify the line so it doesn't match the same value in the next iteration. There we go. We do this to overcome the like as a workaround We do this as a workaround for the overlapping regex matches. Like 9, 8, 3. 9, which is 9, 8, 3, which is like 9, 8, 3. There we go. Then we have grab, or like isolate the first and the last digit or number word. Check if the first digit or check if first is a word number. Convert it to a digit. Check if last is a word number. Convert it to a digit. There we go. Concatenate first and last and parse to an integer. Push the integer to the array. Sum all of the integers together. Profit. And we're gonna put a Christmas tree. Because it's... yeah. There we go. Let's push day 1. Bam, bam. TS store, no. And the workplace as well. I don't like TS stores. I need to add this to git ignore. Git ignore anything inside all of the... there we go. Oh wait. The other one is not matched, so but let me push this one. See this one? It's still not matched. Come on now. Git ignore ds store recursively on every folder and subfolder, yeah. Just ds store? There's no way. I did that. If it's already committed, then I need to remove the cached one. Oh, there we go. Oh, because I already added it. Yeah. Okay, cool, cool, cool. Yeah, commit. Day 1 solution. Bam. Push. Beautiful. GitHub. AOC. Go. Beautiful, beautiful, beautiful. Here's the link to the repo if you all want to check it out. I think this was really cool and productive. We solved it. I'm very happy. Bear in mind, I have no experience with Go before. And this is an opportunity for me to learn Go. And I think we nailed it. We nailed day 1. We'll see how much we can go on and how AOC is gonna kick our butts on what day. This was pretty interesting. This was an interesting challenge that, yeah, put us into a creative thinking mode. All right, let's continue tomorrow, I guess. I'll see if I stream all of the days. Hey, Big, thanks for the follow. I'll see if I can stream, if I have the strength to stream all of the days, every day. I would like to. But, you know. What keyboard is that? Oh, that is the Voyager. That's the let me show it to you. In full screen. Keyboard camera, transform. Oh, I can't transform it now because it's in a group. There we go. Give me a minute. Keyboard camera, come on now. Fit the screen. Ah. There we go. Okay. This is the Voyager. Don't zoom in now. This is the ZSA Voyager. It's a really cool keyboard. It's low profile, mechanical. These little legs can like, they're magnetic, but they're pretty strong ones. And I like it because it's easily transferable, transportable, you know? I used to work with a Kinesis Advantage. And I still have that over here. Let me see. Yeah, there we go. This was my main driver, but I couldn't. How long? It wasn't that long, honestly. I started off with my Q1. This is a Keychron Q1 V2. I started using that one at first, and then I took the time to learn proper, touch typing. And then I started getting some pain in my wrists because, it's not a split. Your hands are basically like at an angle. And then I got the Kinesis. And I got creative with it. I added some custom keycaps. They were cool. But then I wanted to also take Lily58. That's awesome. Yeah. I wanted to take my Kinesis to the office. I go like a few times. And I wanted to continue, comfortably typing and not use my laptop's keyboard. Ugh. So I couldn't take the Kinesis because it's bigger than my laptop. I mean, it's a huge keyboard. So I thought, okay, I'm gonna need something split, and I'm gonna need something portable. And I decided to go with the Voyager. And the Voyager is pretty cool. I really, really, really like this keyboard. It also comes with this cool pouch. Of course, you get pretty much everything you would get in a mechanical keyboard, like the puller, the extra keycaps. The cool thing is that it also had extra keycaps for the home row index. And these are like dots, the blanks. But if you were to opt in for keycaps with legends, they're gonna send you the bump key for Colmac and also for Dvorak, because it's not always, it's not F. So that's cool as well. So you get this pouch. This is the metal plate where you. Yes, I'm using QWERTY. I tried going to Colmac, but I decided it's not worth it. I don't have any pain. I feel comfortable, and the whole world is on QWERTY, so I'm just gonna lock myself to work on my own, like only on my keyboard in Colmac. But then if I were to use a different computer, it has to be QWERTY, and my phone is also in like QWERTY. So I was like, yeah, there are benefits, but I didn't have that much gain, so I reverted back. But yeah, here's a little pouch. It's a pretty cool pouch. In the middle, there's like a little leather piece, and I kind of like that. It's like an interesting detail. for the metal plate. This is where you basically, this is where you basically attach the little legs, magnetic legs. There we go. So they don't fall off. You know, it's pretty cool. And yeah, this is my daily driver now. I easily carry this to my office. They give you like extra cables. There's like a little pouch here. It doesn't go all the way until the end. It's like, here's the end. That's how much, like, that's how big the pouch is, and it's only for the cables. They also give you like extra cables, extra USB-C to USB-C cables for different lengths. So if your laptop is like here in between your keyboard, you don't need a super long USB-C cable. Like a palm's length would do just fine. And they send you like a tiny one. If I can find it. They send like a super, super tiny one. Yeah, it's not here. But yeah, they send, I think like 3 lengths. And it's cool, you know, I love this keyboard. I do wish though that it had like at least two keys for the thumbs. I feel like I can use 2 more keys on the thumbs. Come on now, don't zoom in. MST Perry, thanks for the follow. I have a question. Can I use projects that I have done in a company in a personal portfolio? I guess it depends on how your company's policies are. I mean, you worked on them. Your portfolio is not for selling the project. Your portfolio is for selling yourself to, you know, employers, potential employers. And it's not that the company is going to lose their market because you put the project in your portfolio. It doesn't seem like they're gonna like make you put you in a trouble, but I would not risk it. Yeah. Ask around. You know, like, hey, I worked on these projects, can I put them in my portfolio? It all depends though. Like if you, for example, if you worked in an agency, you might be under NDA. Even like speaking about that you work on that project. I've seen project like that. You should not disclose that you were one of the people who worked on that project. So yeah, I think it all depends. Just like try not to get into trouble. Talk with the people. Y'all. Most of them are all public websites. Well, yeah, I know, but yeah, talk with the people. They might not want, for some reason, they might not want the whole world or anyone public to know that you specifically worked on that project. Because some companies, I'm not sure which ones, like I can't name names, but some companies, like agencies, they could like put you behind the scenes so that the client who you're working the project for, so they don't poach you, basically. You know, if they know that you're working on their project, they might try to just poach you. You know, here's like a little bigger salary and come work for me instead of the agency, etc., etc. I don't know. You know, I haven't been in a situation like that before, never. But I would not risk it. You know, so just ask. Yeah, ask. Ask and you shall receive. All right. Thank you. Thank you all for tuning in. This was a really cool stream today. Really cool stream. I'm going to try to tune in tomorrow. I do have some plans, but I'm going to try to tune in tomorrow and solve day 2 because this is super fun. Thanks. Of course, Perry. Take care, everyone. Happy holidays. And I'm going to see you in the next one. Ciao, ciao.